Hi, Zach Vig, University of Maryland. I have a question for Zach, the other Zach. Anyway, so I was wondering if with this, with landing in the South Pole with Artemis, right, we're going to be experiencing like crazy shadows, super dynamic lighting conditions. How does that factor into photogrammetry? Like, have you thought about how to deal with that? Is it trivial? I don't know.
No, it's a good point. Good question. We have thought about it. Obviously, this test was all in the daylight, pretty even lighting conditions, and that made it a lot easier. In theory, if the lighting doesn't shift too much, so over the course of an EVA, you'll have the sunlight pretty much from the same angle. The individual lights on the suits and potentially on the cart could change the way shadows and illumination are thrown about the scene. So that could throw in some interesting challenges. But I think it could still work pretty well, especially for if you're going to sample a rock. Normally you take pre-sampling photos and then post-sampling photos, and that's from a set distance away with your light shining on the scene. Our argument would be, if you're going to take one photo, might as well take a stereo pair and then get all that extra context. And that should still work even in next to PSRs or in South Polar lighting conditions.
So would you recommend, like, if the astronauts were to bring along like a stationary light source, like, okay, cool, here's a rock, set up this like light pole, would that make things easier?
It might. Then you're using EVA time to set up a light stand,
Right.
which is not as valuable. So a light, like a third-party light mounted on the cart, they have a tool cart that has all of their, the shovel and the scoop and those type of things. You set that up and have it pointed at the scene, so that way you can do your work in set lighting conditions, and the other EV2 could be doing something else and not interfere with the scene. That's probably the best way to go, but beyond our pay grade to make those decisions.
Awesome. Thank you very much.
Sure.
So John has a question online.
Hi, Zach.
For
How you
Zach.
doing? Can you hear me, Zach?
Yes. Hey, John. How's it going?
Hi, I'm good, mate. How are you? That was a great presentation. I actually did some similar work for my master's thesis. I was wondering if you could answer a question, because when I did my work, I built my structure for motion thing kind of myself. I incorporated some stuff, but I built a lot of stuff myself because I found that as I added more images from the video, that it increased the number of errors in the mathematical generation of the point cloud. So I had more and more outliers in the point cloud that were just kind of errors. They were fuzz. Did you have that kind of problem when you were using, I don't know if you used your own software or whether you used something that was bespoke made, but was that a problem that you encountered as you increased the number of images for the point cloud? Because obviously, if you're going to use it like in a planetary exploration sort of situation, then that kind of thing can affect the workflow.
Yeah, for our test, we were just doing pretty short video clips, so probably not as long as some of the video clips you were using, so didn't quite run into that. But Jose Hurtado, who taught us a lot about this process, to answer the question within the question, we're using Metashape Pro. Agisoft Metashape Pro, which is a software that we did not build ourselves. It's sort of an off-the-shelf solution. So Jose is more of an expert on this. He has ways of setting up the structure for motion using the first few frames of the video, but then iterating with additional frames onto that model over time. So you're not building an entire model of like an hour-long EVA from scratch. You're starting with the first few frames and adding a few at a time, and that helps with the point cloud generation, as opposed to trying to do all that computation for a huge model.
Interesting. That's an interesting technique. Thanks very much.
Sure.
Hi, Tim Gloch, Stony Brook University. I have a question for Catherine. I just don't know the answer to this. Do spacecraft rovers typically only have one IMU? And if you can have more than one, would that lead to any potential increases in sensitivity or resolution for your measurements or models?
That's an excellent question. I will say that Perseverance and Curiosity both have two IMUs, as far as I'm aware. Usually they are built, there would be two for redundancy on a mission of that grade. I don't know whether or not rover would have a secondary IMU, or if that kind of redundancy was built in, because the constraints on the mission financially and all that stuff are going to be a little bit different. I'm not 100% sure that a second IMU on the rover would add any necessarily scientific value. That's something that would be really interesting to test on what I like to call a wish.com rover, like a wagon with a hammer duct taped to it. So that is something that's interesting, because the way that the energy is actually received by the IMU, the energy is injected into the ground by whatever the source is that's mechanically coupled to this accelerometer, but then that energy as it disperses into the ground is radiated back up the source as well as through the wheels. And so the entire rover is kind of going to feel that acceleration, but how that acceleration is different from one location to another, and the IMUs are usually as close as possible to the center of mass, so there tends to be a very set location where they tend to be. I'm not 100% sure that there would be added value other than just added redundancy in case one IMU fails. But that's an excellent question and something absolutely worth testing.
Thanks.
We have another online question. John has a question for Ben.
Hi, Ben. How you doing? It was a great presentation. Really interested in Coda. I've got two questions. First one is like, what language is it written in? That's a kind of easy question. And then the next question is, are there any limits on the kind of data that can be integrated? Like, could you integrate, LiDAR data into it and sort of match that up with video data, or are there kind of specific kind of requirements that mean those things can't be connected?
Yeah, it's great questions. It is written in JavaScript, so it's server side and client side are both JavaScript, and it uses React as the front end framework. The data types are unlimited. It's built in a modular fashion, so that if you had something like point cloud data, that's a very unusual data type. Although you could integrate it, but it is a very time-based system, so it would have to make sense from that perspective. So some data types don't care when things occurred. So you really want things like, my example of the XRF, there's a moment in time when that scan is taken. So point clouds work for, say you were going to take a sampling analog and you're doing a before LiDAR cloud, then a sample, then an after LiDAR cloud. You'd want to put those in time context. And then displaying the point cloud, you can basically build a component that either live displays the point cloud in the browser. That's one other limitation. It has to be able to work in the browser, which is pretty much everything these days. Or you could have a video even. We've done this before of like very uncooperative data types. Just take a video of what you're looking at, that photogrammetric video like what Zach was showing, for example. Make that an actual video and stick it in Coda, and now you have it in context.
Okay, thanks very much. Cheers.
Hi, Carl Hibbs, APL. I'm going to try one question for three people. It's for, I think, Kaylee Berry, is that your name? Kayla, hi, yeah, and Ben Feiss and Mark Shellhammer. But Kayla, on human interactions, are there telltales of like when things about to go bad? Like, well, all right, these are signs of things not going quite right. Does that exist? And I guess for Mark, if these telltales exist, would it be possible to maybe monitor them with a computer or whatnot to then do some algorithms to inform people that the behavior is pretty bad, do that autonomously? And then to Ben, would it be possible to have that data actually acquired and sent back so Mark can use it?
Yeah, great question. I'm gonna punt it. I'm not a field leader, and I'm hesitant to give my opinion as the response to that question, but I would definitely encourage you to reach out to Patrick Welly, Kelsey Young, Jacob Richardson, and the field leads in this room, and ask them about their
I might reach out to you, but yes.
Sure thing,
Okay.
yeah.
Maybe still Mark and Ben can answer part of the question. Assume yes, there is, because I assume there would be, but I don't know. Or we could do some deep learning and try to look for it. Anyway, Ben, could that data potentially be somehow sent down in the stream? Is that possible?
Yes, so that's actually a great example of an unanticipated use of this contextual data management type process. So we want to preserve that data in its context with itself so that in the future people can decide to do things with it that are unanticipated. In terms of the actual data that's for that particular application, we are actually live transcribing, for example, using AI of air-to-ground conversations on ISS right now. Now being able to search that data for patterns, and if you had a model that said, is there an attitude type model or some kind of indicator that you could start to make a red, green, yellow type response to that would alert somebody? Absolutely. The data itself is just going to be autonomously well organized.
So I would agree in general that there has got to be a way to use an algorithm to monitor human behavior and send up a red flag. But humans are really complicated. And so something that I might see that it is an unusual behavior for you in a particular setting might not be abnormal if the setting is unusual. So Ben said the magic word, contextual. It's all based on context. And again, it makes it very difficult because by definition, we're sending people and machines into a place where we don't yet have a database, the moon and Mars. So I would say in theory, yes, it's possible to do, but you have to be careful that you're not setting up false positives because almost everything is going to be unusual.
Thank you.
I actually want to jump in really quickly. I've worked adjacent to some machine learning teams within NASA and elsewhere. Before using any sort of deep learning or in the process of maybe creating something like that, I would highly recommend consulting with AI ethicists. Something that concerns me in the wide use of AI is that the ethics of use, especially in a human context, whether that be in the context of war, classrooms, or elsewhere, there just haven't been a lot of studies on the effects on humans of such use. So that's just a flag I want to send up to talk to an ethicist about it.
Thank you.
All right, lots of great conversations. I don't want to eat into the break too much, so we'll take one final question.
Thank you. This is for Ben. Actually, I'm a huge fan. I'm Jose Pagan, Impact from CU Boulder, and I have a very simple question for you. All right, what is data or a data product that you would say is missing from all of their experience working with NASA so far? Like, what is something that you wish they just had more data of?
This is an easy one. Accurate clocks.
Exactly.
Yeah, that all that footage of me holding up the time. I mean, that's not just unique to GoPros. It turns out it's even more difficult to have accurate clocks in space. We take it for granted on Earth because our phones sync with time servers and you don't see it all happening. But the missions that would have a cross different instrument, so like say LRO or something, having a master clock that all other instruments have to ingest and timestamp their data with would be so helpful. It would just make it all fall out of the mission in context already and not require any fudging and fighting and trying to change requirements to try to get things to happen. So that would be on my number one wish.
So something like an old school ship clock. I understand.
Yeah. Or just a clock on the wall that's always in every shot.
All right, we can thank our speakers again.